All right, we are live on YouTube as well now.
Nice. Yeah.
Hey, Safir, Nishi. How are you guys?
Hey, brother.
All right. Cool. Let me just share the screen and see if you can see that. Okay.
Mhm.
Okay. So I can share screen. You can share all panelist. Okay. All right. And okay, let me see Google Chrome. Okay, just see if you can see the window.
Yeah,
I can. Yeah.
Okay, nice. So it's on a loop. So until we start the event, we can keep looping that one.
Awesome. What time are we supposed to start the event, Safir?
The actual event we should be starting at 10:15. Let us for the participants to join. And if you can pass on the YouTube channel and a YouTube link, I will share that as well. Just bring it to
sure. I'll
share
pin
it.
it. Yeah, I'll pin it to the panelists.
Yep. Sure.
You got it?
Yep.
All right.
Let me just start it. Okay, nice. Very good. Okay, it looks like it's working fine.
Cool.
No, things are working fine. Let me increase the loop time. It's looping too fast. Let me see. Autoplay with 10 seconds. Okay. That should do it. Mhm. I'm making a call. I'll be back in a minute. Hey guys, we will be starting in a couple of minutes. Just setting up some stuff. Give us 2 more minutes. Hello everyone. Good morning. We'll be starting the event now. First of all, thanks a lot for joining us on a Saturday evening. We all know, like we are all on Zoom all week, and Zoom fatigue is real. So thank you for taking time to join us on this Saturday. So the Bangalore SiteSpeed Meetup was started like 3 years ago by a group of LinkedIn engineers who were working on the performance and traffic infrastructure. So our aim was to promote awareness of web performance and the best practice of internet infrastructure. Over the course of these 3 years, we have expanded our scope to cover improvements into infrastructure, observability, etc. That contributes directly into site speed. So today we have with us Apu, who is leading the site reliability engineering org of LinkedIn Bangalore. So Apu has been a tremendous supporter and patron of this meetup. Thanks, Apu. And I would like to invite him to kick off this meetup officially. Over to you, Apu.
Hey, thanks, Safir. Good to see you, man. Long time. Yeah, thanks for that. And good morning, everyone. It's great to see you folks here. And as Safir said, right, like on a Saturday morning, to see all those enthusiasm and you folks joining, it says a lot about the passion to learn. So Safir had mentioned that we started this in, if I'm right, in 2018. At that time, Badri was leading the Edge SRE and the entire site speed initiative for Bangalore SRE. And Gopal was the lead for the site speed initiative in 2018. So this is the 5th year which we are doing site speed meetup. It's great to see how far we have come. So back just to reflect, right? Like back in 2018 when we were starting, 2017-18 timeframe when we were starting the site speed initiative in Bangalore, the motivation was that in India, right, at that point of time, LinkedIn was growing a lot, right? Around 47 million was our users or member base at that point of time. And India is a mobile first country, right? Like most of the people in India, right? The majority of people in India were connecting to the internet using mobile, right? So if I remember correctly, around 71% or right percentage of people were connecting to internet using mobile, and they were using sites like all kind of sites, right? Like through mobile. And LinkedIn was like growing, and 47 million we had members, and we were just second to the US, right? One of the big hits we had at that point of time was we were having a lot of these issues with site rendering and loading on mobile, right? Predominantly, we had Android-based mobiles which were accessing the site, and if I remember correctly, it was mostly people were accessing the site on Android platform through Chrome, right? And there was like this mammoth monolithic site which had to be loaded on these mobile browsers, which was like taking a hell lot of time. That's when, under the leadership of Gopal Venkatesan and Regu, who is now our CTO, along with all the SRE support, we launched an initiative called LinkedIn Lite, right? And our objective was to get the site loaded in sub 6 seconds to start with. That was the effort which we started, right? Fast forward today, we did a lot of things, right? And within, I think, like in a few months itself, we were able to hit the target of sub 6 second site load on mobile browsers. And within a couple of months, what we have created out of Bangalore engineering center, right? LinkedIn Bangalore center was adopted to around 60 different countries. And within a blink of an eye, it was adopted to 120 countries. And now currently, what we have developed out of Bangalore as LinkedIn Lite is being used across the world, right? Like it's a flagship app for LinkedIn for mobile, right? So today, with that increase in like reducing the site speed load, right, or increasing the site speed, reducing the latency, right? At that point of time, we were able to increase the engagement on the site by double digits, and even the sessions grew multiple folds, right? Fast forward today, we have around 74 million active users from India. So site speed plays a crucial role in terms of how people engage with the site, right? People have less and lesser patience now, and if you don't have a site which loads quickly enough, you will have people drifting away. That just says that how important site speed has become for internet scale companies. With that, I won't bore you a lot. Just wanted to tell that the initiative which we have started out of Bangalore, which was out of a necessity, right? Like for a developing nation with lower speed internet connections like 3G, 2G internet connections, we innovated to make sure that we can best serve our customers, which has been adopted across LinkedIn in a in a global way, along with improving our business in LinkedIn. So just wanted to reiterate how important site speed is, how important the work all of you folks are doing. I just wanted to thank everyone for taking time this morning, right? A Saturday morning, as Safir said, where you could have done a number of things. Coming to this forum shows a lot of that passion for engineering, right? So let me start thanking all the people who have worked behind. Prem is not here. Nishit, Safir, Prem, Badri, BG, whoever has worked on this initiative, just wanted to thank them. And also I wanted to thank our presenters, Ankit and Mridul, for taking time to share all the knowledge which they have accumulated, right? So with that, I will give it back to Safir to start the meeting. So thanks everyone. Have a wonderful learning experience. Have a great weekend as well. Thank you.
Thank you very much, Apu. Our first speaker is Ankit Nayan. He is the co-founder of Signos.io. Signos is a observability platform, and he is here to talk about, like, what was the reason when you have, like, so many monitoring tools and, like, stacks and SaaS services out there. What is the need for, like, building a new open source platform for observability? Thank you, Ankit. You can start your presentation.
Sure. Hi, folks. I'm Ankit. I am CTO at Signos, and thank you, Safir, for introducing me. And thank you, guys, for coming on a Saturday morning. So it is a difficult divide, I understand. But yeah, so these extra hours make efforts that counts, right? So I'm going to talk about a word that has been used for the last 2 years very profoundly in terms of monitoring, tracing, and observability. So at Signos, we are trying to build an open source observability platform. We went through different solutions in open source SaaS, and we tried to understand what was the difference between different segments there, and what was the need to drive to build another observability tool that is Signos, right? So I will like to share my journey, what I learned from using Prometheus, Jaeger, and now why are we building Signos. So I would like to define observability first. As we said, so observability, the word has been derived from the control theory, and what it means is you should be able to determine the internal states of the system when given you have an external set of outputs, right? Given an external state, you should figure out what is happening inside your system. Now, when we apply that to DevOps domain, it will be something like we try to understand what was there in your infrastructure, what was the state of your application, what was the state of your CPUs and databases when things are going vary in the output. And for us, the output here would be the user impact, right? So let's give an example, like if a product manager comes and says, we have some failing payments, customers are complaining about it, then we should be able to drill down into things and just say simply that, oh, we are using 3 or 4 payment channels, and this payment channel A is sending 5 excess errors. So that's why some of our calls or payments are failing, right? So another example would be like, if you are loading a home page and you feel it is a bit slow, a product manager would just come to you and say, I feel the website is slow. Can you look into things and tell me what it is? And can you fix it out? Now, there should be a system where you just go and figure out what was the reason for that. Like, you should be able to answer service X by team Y and API Z is slow. So that's why it is taking the homepage to a lot of time to get loaded. Okay. With that definition, we usually proceed towards observability by defining the three pillars of observability. The three pillars are said to be metrics, tracing, and logs. Metrics is like an aggregate of any of any item that you can say, like even if let's say how many times in a day do you breathe, or how many steps in a day do you take. So that is also a kind of metric. It's like an aggregate of a number, right? And uh, tracing is like you track a request where it goes and wherever it goes. Like from the time a request hits your network boundary, it goes to load balancer, it goes to service A, service B, instance X, Y, Z, then to service C, then to, let's say, database call, and then it sends the results back, right? So tracing or distributed tracing is about tracking the request from the income, from when the time it comes to our load balancer to the end of the database call. You should be able to see all the events or spans. Here, span is the basic unit of distributed tracing. So you can call a span to be an event. Like so, so you should be able to figure out what are all the events that have been emitted when a request has moved through different applications, different machines, and database layers, right? So it's like tracing a complete individual request. Next comes logs. Logs is something that we are very familiar with, right? So we have been sending a lot of logs, whether meaningful or not, that's a different question. But yeah, so we have been sending a lot of logs into our systems to look down into, like, we usually go if something is breaking, we like to see if there's a function call, we have put some logs there, and whether that log has been called or not, right? So even we try to give some sort of a structure to logs by printing status codes, the latency, the time taken, and different methods that are being called. So like, so that it is easy to figure out those things out in visualization. Now for metrics, there is a great open source tool called Prometheus. I think most of you would be familiar with that. Prometheus is a pull-based metric system which scrapes metrics or metrics data from different target system that you can define and on a fixed interval. Right? So let's say you have 5 applications, and all those 5 applications expose their metrics on some port and slash metrics endpoint, and their purpose is just that. So all the 5 endpoints will be exposed by every individual application, and Prometheus, after every fixed interval that you set, it goes to those endpoints, scrapes the data, gets back, and makes some meaning out of it. Like it stores, it gives a query layer, it gives visualization and all. Jaeger is a tool that is a distributed tracing backend. It's a tool that has been open sourced by Uber itself, right? Like Uber has a very large infrastructure and very large number of microservices that it runs. So tracing becomes crucial there, right? So, and when it comes to logs, we have for quite a time been familiar with Elastic, that allows you to do a free text search in the UI of Kibana, and some sort of regex and gripping can be done in the visualization layer, right? So you can figure out that some pattern is being repeatedly, and you can generate count and rates based on that things, right? And Loki is another open source tool in logs that is open sourced by Grafana. What Loki says it is different is that it makes the storage of logs very efficient. And how is it does that is by using structured logs. So structured logs is basically rather than you search on a full free text. So searching is a very extensive operation because you need to index by some values that you might be able to query, right? So that you have to index by keys. So when you have a free text and no structure to the data, it becomes very difficult to index, and it takes a lot of storage needs to index data. Right? And when the blocks are structured, it will be like a set of key value pairs, like status codes is equal to 2xs, time is equal to xyz, service name is equal to z. So it becomes very efficient to store them by the keys of these parameters, right? So it's low-key optimizes storage by indexing by set of keys, and you can visualize them in Grafana. So the logos that I have put is starting from the left-hand side, Prometheus, then Jaeger, Elastic, and Loki. Right? Now, there's an interesting survey from CNCF. CNCF is basically a Cloud Native Computing Foundation. That's an umbrella brand where many of the open source cloud native projects are hosted nowadays. So it's doing a great job there. And the report says that 95% of the users that responded to the survey were using metrics and logging. And roughly 74% of the users were using tracing. So tracing is still growing. It started taking momentum around 2015, 16, and it is evolving with the stack, right? And the distribution here on the chart is whether most of the users try to host it in-house or they use a hosted SaaS service, right? And third is that I do not use this service. So I see we have around 60% of the users using this service in-house and hosting it somewhere in their infrastructure, as compared to using SaaS. So roughly 37%, 35% of the people are using SaaS for monitoring and logging, and the comparatively for tracing is roughly around 45% of the users are using are running it on premise, and 30% of the users are running using SaaS. Right. So it's a very genuine question that came to my mind. Why would someone try to self-host things in their own infrastructure in 21st century, or when the world has been moving towards cloud? So as we see, most of the vendors that we have in this space, they are very much closed source, and there has been some sort of magic that when it comes to the agents that they have built up, right? So nowadays, developers or the DevOps engineers want full control of the configuration and the things that run in their own infrastructure. They like to play with the configuration parameters and the knobs and tune up and things down a bit, right? So that's one criteria for choosing open source and self-hosted projects. You can, if there is anything specific to your business, you can build that on top of open source tools, and you don't need to go to the Slack or GitHub issues of other vendors to get your work done, right? And the SaaS players in this industry are very costly, right? So they charge by per machine, right? So that's against the pattern of horizontal scalability that we try to achieve in today's world, right? So with horizontal scalability, we mean your application should be able to handle the spike in your load by just extending the number of machines that you have. Like you have 5 machines running, you want to run 15 machines, good. Just to spin up the number of machines, and your application should be able to handle the load, right? So, and when you charge based on the number of machines rather than the data that you are sending to the and data that you are using, and so it makes little sense to me, right? Apart from there's a cost of sending that data out from your infrastructure into the boundary of the SaaS provider. There has been a problem of vendor lock-in with this today's vendors, right? So if you try to use Datadog or Neuralink, they give you a library that you can put into your application to instrument the code. To instrument the code, that I mean is that you can write your export your custom data, or you can send some custom metric that is specific to your application by writing code, right? And when you use these vendor-specific libraries, after 2 or 3 years, you see that a lot of code and vendor-specific things have already been written in your application. And becomes very difficult to move out from a company when multiple applications have been instrumented with these specific libraries. So that is called vendor locking, that you cannot move out of a vendor. Now, OpenTelemetry is an open source instrumentation framework that gives you the leverage to be vendor agnostic. Right? You can now instrument with OpenTelemetry libraries, and all the vendors will have to be compliant with OpenTelemetry or support OpenTelemetry to ingest that data. Right? So we choose OpenTelemetry over vendor-specific libraries now. You also, apart from that, today a lot of new privacy laws and security concerns have been arising, like privacy laws like GDPR, CCPA. GDPR is basically keeping data of European customers in Europe, and CCPA is that if a user at any day wants to remove the data from the company that they are subscribing to and not ask them not to share with any other company, that is CCPA, right? You can ask literally Facebook to not share the data with someone else, right? But that is still evolving, right? So due to all these reasons, it becomes very much important in today's world to try to have some sort of data governance or control over your data, right? And in today's days, Kubernetes kind of orchestration system has made hosting applications and infrastructure a bit easier, so that gives you a little edge. It is now not that as painful as it used to be earlier to host in your infrastructure. Now, I like to quote a text from Elon Musk a few days back only. So it was a tweet that Tesla is using only internal and open source software, right? So why not us? So we also can be part of that contribution to the society. With these terms to going towards open source and self-hosted systems, I'd like to start with things like Prometheus, right? Prometheus is a metrics-based system that gives you an aggregate of how a particular quantity or thing is performing, like a metric is performing, right? So I guess you must be familiar with Prometheus and all, right? So it's very easy to get started with. You can get started with smaller number of teams. You just need to add a few exporters to get CPU, memory usage, storage, network layers, and Kubernetes state metrics all around, all up and running. It's very to see useful and insightful metrics in the Grafana dashboards. You have alert as code, and you have powerful alerting. Like you can group by any dimension of the metric. Like a metric has different kinds of key values pairs to filter it out, and you can group by or sum by any of those parameters or the key value pairs, right? So that's a very powerful thing that Prometheus provided. Apart from that, Prometheus is a time series database, TSDB, that is very efficient on storage on disk. So it is quite good in doing the job. And when it comes to comparison with a SaaS vendor, when you can instrument with Prometheus and send the data to backend that can store those metrics and display in Grafana, it is very much cheaper as compared to any metrics or custom metrics or business specific metrics that you would export to a SaaS vendor. Like Datadog charges for $5 per 100 of metrics that you can send to them, and 100 is literally nothing, man. So it is very costly. So business specific metrics can go up to 1,000 to tens of thousands of metrics to 1,000,000 metrics, and it becomes very costly at those scales. Now I'm going to talk things that are hard in Prometheus. Like getting application metrics is difficult in Prometheus, right? A few of the exporters give you the basic application metrics, but deeper application metrics like what is the latency breakdown into each different component of the application, what is the RPS, like request per second, what is the latency of individual endpoints, if an application using Redis, then what is that time taken? So all these things are a bit difficult to get into. So, and when you, the way Prometheus works is by using exporters, right? So you have to have exporters for each and every component that you want to monitor or send metrics to, right? So managing those exporters as sidecars become a bit difficult to manage and gives you some overhead, right? Prometheus by default is not horizontally scalable and does not provide long-term storage. Right, long-term storage means you want to store the data for 12 months or 18 months. If you want to increase the capacity of Prometheus, you'll have to increase the storage capacity or the CPU capacity of the machine in which it is running. And that is against the horizontal strategy that you spin up more machines, your application should be scalable. Right? And Prometheus by default stores the data in the disk. Right? So to use for long-term storage and horizontally scalable, we use other tools like Thanos, Cortex that we'll talk of later. Then the time to set up these things in Prometheus to make it work for a bigger team with all the application metrics and the storage system and horizontally scalable things is roughly around 1.5 months it is generally the time that it takes to set things up, right? And what do you do with the metrics once you figure out that a metrics is going wrong, right? Metrics is the first step to do an RC. What is the next step? So Prometheus is just a starting step that you get to know that your application is sending 10% error rates. Your application is down, your endpoint is down. But what exactly is making it slow is the part of RC that cannot be done in Prometheus, right? So I did some hands-on, I gave a trial to build those application metrics out of Prometheus. I built some client libraries. Like client libraries are basically some packages that you can install in your application. Like if you're using Python, then you can install any library by doing pip install something. For Node.js, you can do npm install. So those are client libraries that I'm talking of. So I built some client libraries that can be put into an application, and it will automatically export some metrics in Prometheus format that can be exported to Prometheus and visualized in Grafana. So, and this is the first screenshot of the application metrics that I tried to see. So we can see the error percentage and request per second RPS by status codes like 2x's, 5x's, you can see. So you can be a bit worried at why are so many 5x's coming. The overall request per second, the P50, P90, and P99 latencies of the application. P50 is basically how the 50th percentile of the request see the latency. Like 50% of the requests that are coming, how do they see the latencies, right? P99 is 99. How do the 99% of the request coming see the latency of your application? So these are very important profiles when it comes to monitoring the latencies. And average is not that good. Right. So apart from that, we can monitor the application latencies by endpoints, like which is specific APIs or endpoint is slow or not. That given if an application is spending time over Redis, Mongo, or different components like making an external call, you should be able to see in an overall diagram like this left-hand side bottom diagram that let me try to move it. It doesn't. So this gives you a breakdown how much time this application spends in Redis and Mongo versus the application logic. So if there's a spike in any of the metrics here, you can figure out if Redis is the cause for that increase in latency. And again, application latency by endpoint. Another thing that I tried to figure it out was if an application using Mongo, how much calls to the Mongo and Redis is this specific application making, and how much latency is this specific application facing from Redis and Mongo respectively, right? So Redis and Mongo can individually be observed as a different set of application, but how this application is contributing to the latencies and how this application is observing Mongo database or Redis database to be, right? And if you're making external calls to different APIs like downstream services, like card service, payment service, or user service, and making external calls to somewhere else, you should be knowing that whether those external calls are slow or not. So in this, I tried to give the average duration of the external calls by address. How many calls are you making? Address is basically the address of the external API, the URL of the external API that you're calling. And by individual URL, how much time are they taking? And just give you a fair sense how the external APIs are performing. Now, once I tried to figure out the problem of getting detailed application metrics out, I tried to use or to solve for long-term storage and horizontal scalability. So this that using Cortex, right? So this is our complete architecture of Cortex, and it uses distributors, multiple distributors and ingester instances. It then stores to Cassandra. You have console for managing the identity, then query service is there, querier is there, ruler is there, table manager is there. So it becomes a bit of complex to manage things when there's a huge amount of data, like ingester sometimes hangs a bit between, and the complete architecture is very difficult. And all this to just get the metrics out, right? So retreating again from the past, the problems that we had with Prometheus was long-term storage, deep application metrics, and doing RCA, like, right? RCA, how do we do the RCA? Root cause analysis. So there comes the picture of distributed tracing that is done by using a tool called Jaeger. It's an open source tool by Uber. So I've used this tool also to do that. So this is an architecture diagram of Uber, where one request goes to multiple other services and different databases to get the result out. And to give you a brief background again about what distributed tracing is, that whenever a request starts from the load balancer and goes through multiple services before going back to the user, so you need to track the request in every step that it is going, service A to service B to service C to service D to database. So you should be knowing what is happening in each of those steps or the life cycle of the request, so that you can tell, yeah, this part of the request was slow or erroneous, so that's why we got an error there, right? So this is the complete architecture of Uber, and it is fairly complex. So they need some sort of distributed tracing system. So when you have increasing number of services, to try to have a picture that you're not able to figure out the root cause of things, it's time for you to getting started with distributed tracing. So the general trends of using distributed tracing is the number of microservices going up, and in today's world of horizontal scalability, the number of machines going up to handle a spike load. So these things generate demand for more detailed tracing or tracking of the request. Right? Now you need to figure out if my service is slow, I am the owner of service X, was service Y down or Y service Z down that impacted me or not. So I need to know what are the upstream and downstream services and how are they performing. Right? It might not be the problem of my service. It might be the problem of their service, right? Which instance or which machine or node is having an issue? Are the CPU or memory hogging so the requests are getting slow? Or what was it? What was the reason? Which deployment version was it? Did I deploy something a day back or 2 days back that is making something slow, or is it all the application is slow at a time? Right. So drilling down into these details is I would say is the stronger point of using distributed tracing. And this is a hot rod example that is given by Uber as an example to demonstrate distributed tracing. Hot rod is basically a ride hailing app, that is ride on demand. ROD is ride on demand, right? I have provided a link for the blog, and you can go and drill down into it later, right? This is a sample application where you just click on a few buttons and you call a cab, and the UI displays a few items like how much time will be taking for the cab to arrive. It passes through a set of different services, like it goes from the front end it goes to customer service, there is driver service, and it goes to MySQL and Redis to query a few parameters and sends the data back to Jaeger. Right. So this is the Jaeger UI that gives you an understanding of what how the different individual request is performing. So this is one of the request 1, request 2, request 3. So we call this as individual request. That is one request is there, right? And one request has 51 spans, means it has 51 events. And in all of these events, there were 3 errors. It went through different services like customer, driver, front-end, MySQL, Redis, and route service. Redis took 14, emitted 14 events. MySQL emitted 1 event. Front-end service emitted 24 events. Okay, this is the total time that it took for the request to complete. Here is the list of parameters that you can filter by. Like you can filter by duration, the service name, and some tags. Like tags are basically annotations that you can put into any event, and you should be able to filter that using that. Now, this is the example of a trace view in Jaeger that is give you a much detailed understanding of what it is happening. The front-end service is calling another front-end service. So these are the parent events and these are the child events. So this is the front-end service, then it's calling /get customer endpoint, and it is going customer service, and the customer service is calling MySQL. Then another parallel to this request is this request that it calls a driver service. The driver service calls multiple times Redis. So Redis is get driver. It basically tries to get a driver ID. Now again, some more queries. So what you can see is our latency distribution. Like if a request is taking 1 second, how much time is spent where? That gives you an idea about how the request is going through. You can see that the parameter here is in staircase, right? So this Redis event started after the end of this Redis event. Now this Redis event started after the end of this Redis event. And you can see when the first event has stopped, the next event had started for Redis. So it means it is a sequential call, right? First one Redis, first request gets over with Redis, then it calls a second, then it calls a third, then it calls the fourth, until it gets a correct response, right? So you need to check whether in your architecture this is sequential list of calling Redis is needed or not, right? So it may not be needed to call them sequentially, but in this application architecture of this application, it is needed, right? It waits till there is an entry in the Redis to get the data out. And these two are erroneous events, right? Redis timeout will be the error. You can see it here, right, later. So this is very useful in understanding how a request went through and what took the longest time in the request. When you click on a specific event, like here is a MySQL event that does a MySQL select query. So when you click a specific span or event, you get to see some details about it. Like you can see the query, kind of query that was there. Usually the customer ID is not passed as numbers or the exact value, it is passed as question mark or something like that to maintain the PII. And it also has some logs. You can also send some sort of logs with every event or span. Right? So this is very contextual, right? And the duration of the event is also there. So this gives you a huge amount of information about every event that is emitted by the request. A few of the things patterns that you need to look into your tracing data is here. So you have to see whether this look for the error markers. These are the red error markers in Jaeger. If you want to figure out why something is slow, look for the longest span that is taking most of the time and try to optimize that, right? So that is a good indication that where you need to filter those things out. You need to avoid some sort of sequential execution, right? This is a typical example of last set, right? Multiple Redis calls being made back to back. And this gives you an idea that some sort of sequential execution is made. So some sort of ORMs, that is object relationship mapping, that's a database layer, mapping layer above in application. So some sort of logic you may be writing right, but the application, the ORM is converting into a database query that makes it sequential and not parallel. So there can be multiple other things that can go take you to the route of going sequential execution. So you need to make sure that your application is correctly designed, that it is whether it should be sequential or not. Also be wary when all the events end at the same time, right? So there seems to be something fishy about it, right? what can go wrong here? So one of the things is that there can be connection timeouts, right? So if all the requests are waiting to be connected to a database or an application and they are not getting through, and after 60 seconds, maybe they are timing out all at the same time, right? So this is an indication that something might be going wrong there. You need to look into it, right? This is the architecture of Jaeger, where how does it usually work is you have a client library that you put into your application. It starts sending the data to an agent that is installed in your machine. That agent then pushes the data to collector, which basically collects data from different agents, and the agents collect data from different clients, right? Now the collector does some sort of processing and sends the data to database. The database can be Elastic, Badger, or Cassandra, and the Jaeger UI queries from database and shows it to the UI. Right? So there is also some sort of sampling that can be done in when it comes to traces, because an amount of request on the data or the events will be huge to handle, humongous the amount of data, right? So you can sample the data by having some sort of sampling strategies, like one of the strategies are adaptive sampling, a rate limiting strategy, probabilistic sampling. So what you can do is you can, in adaptive sampling, you can say that you just want to filter 50% of the request for service X and event Y. So you can also specify the name of the event to filter. So what I felt missing in distributed tracing was that the UI of Jaeger was basically minimal, right? So it can be improved a lot based on the user experience. It also lacked a few capabilities, like you cannot run aggregates after filtering the number of events or the traces, right? So what it means is, once you have a set of filters, like I want to filter, see the traces or events for service A, the event name B, latency XYZ, and parameters or the tags you have set something like customer type is equal to gold, right? So you can put those kinds of tags like customer type is equal to gold, payment channel is equal to PayPal, and all those parameters, whatever you want to add in an event, you can write it in your application, right? So in the UI, you go and type filter by customer type is equal to gold. You are only interested in this specific customer type to give them a specific service, right? But you cannot see, after you filter these traces, still you see a huge amount of traces. You do not know which trace particular to look into to optimize, to find out the errors. One trace might be sending error, another trace might not be sending error with the same one, right? It might be slow. If you're seeing 800 milliseconds, you don't know whether 8 milliseconds is the average for that type or not, right? So you need to have some sort of metrics to get you an overview of how the overall system is like with these set of filtering criteria. And then if any trace or request or event is going away from those settings of baseline or those set of metrics, then you should be able to look into it, right? Apart from that, there is no alert setting capabilities in Jaeger or distributed tracing today, right? So we need to have some sort of alerts, right? The data should be mixed and matched with metrics. You should be able to filter out by different keywords, and you should be able to set alerts. And as a need for an enterprise, it needs to have multi-tenancy, like different teams in the organization can use it. There needs to be different set of controls for different team owners, and all those kinds of things are missing in Jaeger. So we thought there was a need to build a better distributed tracing system. And with the Prometheus, we learned the Prometheus is very good at getting you metrics, but it doesn't do the next part. Jaeger does distributed tracing well, but it doesn't give you aggregates or the metric side of events. So the metrics data and the Jaeger data, the distributed tracing data is separate from each other today. There is no correlation between them and in the charts, right? So there is different individual UI also where you can see them. So that's the brief that both of these individual silos miss when it comes to observability. So I tried to bring together those both open source systems and try to build an open source system here. And it was kind of difficult, right? So let me give you an example. Like the client libraries in the application send data to OpenTelemetry collector. The collector, this is what I tried to build to give a uniform front end for both metrics and traces using Prometheus and Jaeger tools at backend and in a scalable system. Right? We get data from applications to OpenTelemetry collector and different machines. They send data to proxy. After authentication, they are sent to Prometheus server and Jaeger collector that runs on individual tenant basis because these are not multi-tenant. You need to run it for each and every individual or type or team or tenant. So you have to run both Jaeger for distributed tracing and Prometheus for metrics, and each one for each tenant. Then you need to push the data to Kafka. Then for tracing, the Kafka sends the data to Jaeger ingester, which writes to Cassandra. The Prometheus servers and the metrics go to Cortex, which is where they have distributors, ingesters, cache, memcache, and all. And the ingesters write to Cassandra. And we remember, right, how heavy in the architecture was. Now, after Cassandra, we have two different queries, like one for tracing, one for metrics, and a unified front end, so that we can query traces from this query and metrics from this query. The complete architecture actually became very heavy to manage, and it was difficult to maintain that, right? So what we felt was we lacked a complete system where we could seamlessly use metrics and traces, moving from data of metrics to data of traces, and those should be correlated, and the architecture should be a bit simpler than that, right? So it should not be difficult to, it should not be like that we are maintaining metrics and traces pipeline independently. Okay. And at the same time, we did not want to miss the features of the SaaS products that we have, right? What are the advantages of SaaS product? That is, we should be getting things out of the box, right? Metrics, traces, this should be out of the box. We should not take 1.5 months to set things up, right? It takes a lot of time for the developers to do things. Right? So with these goals in mind, and something we started building Signos, and the key things that we want to cover while building Signos is that metrics and traces should be in a single pane. There should not be independent pipelines to maintain all of them. The UI should be seamlessly browsable. You should have powerful trace aggregation capabilities that we missed in Jaeger. Like if you're having a customer type gold and you want to set important alerts on that, you should be able to do that in tracing, right? Then you can easily set out the retention rules, like you want to store for 1 month, 3 months, or 18 months of data from your dashboard. So, and out of the features that requires minimal developer efforts, the cost should be a lot cheaper than SaaS vendors. So I had a benchmark on the cost, and it was coming out to be 10x cheaper than Datadog for the benchmark that we took and for the instances that we took. Right? Have a read there. It should be open source, and so that you can have control of the data. You can self-host it. You can add independent modules on top of it. The architecture has to be hugely scalable because it handles a huge amount of data. So we decided to use Kafka to handle the back pressure, and Druid gives you the power of running aggregation capabilities on the data. So Druid is a database that is a real-time analytics tool or database that gives you the aggregation capabilities to run on top of any data, incoming data. We try to support OpenTelemetry out of the box. Like OpenTelemetry, we remember from the past that OpenTelemetry is a vendor-neutral instrumentation framework where you can instrument the client libraries and get data to the collectors and the distributed tracing system and the metric system. So right, so that's we support. We like you to be not vendor locked in, right? And for enterprise features like the RBAC controls, like role-based access control and single sign-on, we also plan to have an open source anomaly detection framework that should be very that is very important to filter out the noise of the alerts that we have today. That will also be open sourced and should work with different systems like Prometheus, Jaeger, and Signals, right? So we'll try out different algorithms for that and see where that is going. So this is the architecture of Signals. Like different applications send data to hotel collector, open telemetry collector. Open telemetry collector writes to open telemetry to a topic in Kafka. So when that is written, there is a stream processing going on that we extract some sort of metadata. Sorry, give me a second. We extract some sort of metadata and we store the data to Druid, and Druid at backend stores S3. We have a query service in the front that queries the data from Druid, and it stores in the front end using React, right? So this architecture is hugely scalable. That Druid is believed to be scalable in Airbnb and Lyft kind of system. So it is very much trusted. And Kafka handles the back pressure and the events very well. Like these are the different components of Signals. That is open telemetry collector, Kafka, stream processors, Druid, query service, and front end. Happy to talk about them more. I'd like to give you a demo of Signals that you might find interesting. I'm sorry about the voice if something is going wrong. So this is the individual dashboard that you see when you come to Signals. These are different services that you can see: the front-end service, customer service, driver service, route service. Again, from our application sample applications of hot rod application. This is the P99 latency that we see, the error rate, the request per second. When you click on one service, you get the details of this service. This is the application latency that you can see. This is a 90 percentile, 99 percentile. This is a 50th percentile of the request, and the request per second that you can see. The endpoints that we have here, right? So, sorry. If you want to drill down into any of those metrics, what you can do is you see that here is a spike. You can, if you want to drill down deeper into it, you can click on the view traces button. It will take you to the list of traces for that particular service. You have all the events that are being emitted for that service. If you want to drill down, let's say filter by latency, you can use 1 second, and you want to see all traces that are more than 1 second. You can filter it out. You can see all the events that are taking more than 1 second. You can sort them up here. You can click the individual trace ID. So this is basically the same different way of representing the same data. It's called flame graph. So front-end service calls the another front-end service. This calls driver service. The driver service calls Redis databases, and different individual queries are there. You can see the ID. You can see how much time is the individual service taking. This is the customer service. The customer service calls MySQL. The MySQL takes 1.8 seconds. And this is the query of MySQL. So you should be able to figure out this is the total time of the request and how much time is the MySQL taking. So it helps you to drill down much deeper into it. And let me show the aggregation capabilities of Signals. So let's try to filter by this service name. Okay. Now I have put some tags or annotations in my application, like HTTP URL. I'm calling this application is calling an external service that you can see, and you can filter out by typing the endpoint of the external service that you're using. And when you apply that filter, so all the events that are emitted with this service and that equals this endpoint, you should be able to see all those events here. Okay. So my point is there can be thousands of events here. You want to see a benchmark or a baseline, how things are happening, right? So if a customer type is gold here, if there are thousands of events, what is some aggregate numbers? So this is the graph that we are talking about. This graph is built on this filtered data, and this is the P99 percentile of the filtered data, trace data. So you should be able to see how is the P99 percentile performing for this set of filters. So if it is customer type is equal to gold, means how are the gold customers feeling your latency? All right. So these are very powerful features that you can see here. We'd love to talk more about it offline. So for the timing, let's move on to the next slide. So now a point was being out of the box, right? So what things you need to do to get those sorts of graph and that sort of data started? First thing that you need to install Signals. Installing Signals is pretty much easy. You have the links for the relevant things also here, but you just need to get from the repository, go to the deploy folder, and run an installation script. That's all. It installs Docker on a machine. It installs OpenTelemetry collector, the different backend components that we have, Kafka, Druid, and query service. It also deploys the UI, which is now accessible at the port, right? So you just have to get from the repo, install dataset, run, and Signals is installed. Now you have to instrument your application using OpenTelemetry client library. What it means is Signals is ready to receive data, but there should be someone who is sending data to it. And that is your application. An application starts sending data when you put the client library into it. So for an example for Java, this is how the docs look like. So this is a jar file that is given by OpenTelemetry. You just need to download it. You need to specify a few variables, like hotel exporter endpoint is where Signals is hosted. Basically, Signals is hosted in this machine where you have run this set of commands. Put the port number there. You need to set the name of the service that you want to see in the dashboard, and you just need to define Java agent to the path where this Java library that you have downloaded by OpenTelemetry and your application jar, right? So once you have run this application with OpenTelemetry jar and some with the endpoint of Signals, it starts sending data to Signals. And Signals does all the crunches, all the incoming data, it generates metrics, it shows in the UI. So all the dashboard that I showed you earlier in my application in the demo is actually generated by using this installation command. So this is pretty much out of the box, will not take you 1.5 months to check things up. Right? If you want to send more data or any business specific data that you can see, do you want to see in the dashboard and filter by, there's always an OpenTelemetry SDK that you in your application that you can use to try and send more data or any business specific data to your application. Right. Thank you for Saket. Thank you for being a wonderful virtual audience. Reach out to me at Signals, Ankit@signals.io. I'm active on Twitter and LinkedIn. Thank you, folks. And sorry for the breaking voice in between. So I'm open to Q&A if people want to share or learn more.
Thank you, Ankit. That was a wonderful talk. Covered a lot of ground, and definitely, in this time of observability, gaining more importance is
Right.
very interesting. The participants, if you have questions, either raise your hand and we will unmute you, or you can put your questions in the chat. So far, we have one question from Vijay. This question is, whether C#.NET frameworks are supported on OpenTelemetry.
C#, I guess yes, they are supported.
All right, so we will wait a few minutes for more questions, and then if there are more questions after that, we will pass it on towards the end as well.
I'll paste the link to the .NET library in here, but it is a bit difficult to understand completely from the GitHub repo. So, but yes, it does support .NET and C#, and if you want to discuss more, so you can reach out to me. I will tell you the easiest way to do things out, right? But yes, so you can instrument your application using .NET, and OpenTelemetry does support that. Right. So anonymous attendee. One thing missing is logs. Any plan to include data? Right. Right. A very interesting question. So uh, we are planning to go ahead with metrics and traces for now. Logs is in alpha stage in OpenTelemetry. So OpenTelemetry has a plan to go to all pillars, from metrics to traces to logs. Logs is in alpha, and it is very much inclined towards using structured logs. I had a chance to view the GitHub repo of how the specs are going to be. So it's going to be in structured logs, and logs will be, when the logs mature in OpenTelemetry, we'll definitely include that in our stack itself. Yeah.
All right, folks. Any more questions? Please raise your hand or type either in Q&A or in the chat.
Or feel free to reach out to me after the events also. I can talk more about it there.
Yeah, there's one more question. Just a general question: is Signos capable? What Lightstep does?
Just
So,
is
Signos
Signos
do
capable? What Lightstep does? Okay, that's a good question. Currently, Lightstep has a lot of features that we do not support, right? But the premises of our open source project is such that we can handle all those anomaly detection and machine learning capabilities. So actually, anomaly detection and machine learning is in the roadmap, and we plan to plug it out from Kafka to an app to a monitor to an anomaly detection framework where we can work more on that, right? But today, no, we are not equivalent to the capabilities that Lightstep does. But going forward, I would say in a year, yes, we should be able to give all those machine learning and beautiful dashboards that is there in the basically. So we are going to plan to have change detection also, like if something has changed in your infrastructure or some deployment version changing or different kind of things, right? So we'll incorporate those also.
I don't see any more questions now. Let us see, folks. If you have more questions, please feel free to ask. Angez will be around. We'll pass on those questions towards the end of the next talk as well, if needed.
Sure.
Or we can connect you with him directly as well. All right. So thanks a lot, Ankit. Please stay around, and we will get into the next talk after this. Thanks a lot.
You're welcome.
All right, folks. Up next, we have Mrudal Malhotra from LinkedIn here. So he's going to talk about their experience in implementing a CDN and choosing and implementing a CDN in China. As you know, there are a lot of challenges for setting up any internet infrastructure in China, and he will talk about that. Mrudal is from the LinkedIn Traffic SRE team, which handles all the traffic ingress and it is all they are technically responsible for every single byte that goes into LinkedIn as well as goes out of LinkedIn. Mrudal, welcome, and over to you.
Thanks a lot, Safi. Thanks for the kind introduction. So I apologize in advance if there is some noise. There's some small construction work that just started just a while back. So yeah, if you hear any disturbance, sorry about that. I hope you all can hear me clearly.
Yeah, you're good to go.
All right. Okay, I'll just share my screen. All right. So this talk is basically discussing how is it that we tried and evaluated CDN in China. And it's called Silk Road to Cash Hits. So I'll just get started with it. Second. So yeah, Safir already introduced me, but just so that for the sake of repetition, I'm Mridul Malhotra. I'm currently an Edge SRE here at LinkedIn. So handling steering and CDN primarily comes under our domain, and ensuring that we have optimal experiences for LinkedIn members. So let's just sort of first try and go over what this talk is going to be structured about. We'll have an introduction. We'll just go through basics of what is a CDN, and then have some background on why China. Why is it that this talk is about China, and what are the caveats that you might face in China? Then we move on to the actual evaluation phase, where I discuss with you the idea and the approach based on what the idea was, based on what this abstract notion of evaluation would be. And after we have had some insight and some understanding of how testing could happen, there is going to be a discussion on one case study. It's basically our learning. It's basically our experience of onboarding a CDN in China. So there is one such instance that I would like to discuss, after which we have a conclusion. This will summarize everything, and then we'll take questions in the last. Right. So I'll just get started. To give a brief overview of what a content delivery network is, it is just simply a distributed system that consists of servers which act as a cache. Generally, when you have any traffic that is coming to your site stack, generating dynamic content obviously is the first priority, and it depends on how and where and which user is actually contacting you. That is definitely the first priority. And alongside, there is also the role of optimizing that particular request, right? Because it's not just the content that you have to serve; it's also how efficiently can you serve that content. So a CDN is a simple idea. It's just a distributed cache, and it tries to serve images, and it tries to serve it basically tries to serve some content, especially static content, like scripts, images, videos, and all of the other assets. The reason for that is because generally, when you look at a website and when you look at the different components of how a DOM tree and its various parts are built, and as well as the entire set of resources that are required for any web application or site to function, the majority of the chunk in terms of payload is going to be your images. It's going to be your videos, and it's going to be these assets, these scripts that are not really going to change as frequently as a dynamic HTML probably would. So it just makes sense to come as close to the user as possible, bridge that distance, and say, we have these edge servers which will act like a cache and which will try and serve the content in an optimal fashion to you. I'll take a very short example of how a CDN works so that you have more clarity on what each component is. So let's say we have our origin server, which is actually hosting all of the static content that we just talked about. It has all of the JS that we would want to serve for our website. And the dynamic HTML goes to the mobile, and they say, oh, we want this particular resource. It's asset.js. Asset.js goes to the CDN, but the cache is empty. So it's a cache miss. It does not exist in the cache. So the CDN in turn has a backend, a request on its backbone to the origin servers that it is configured to, where it gets asset.js. And when it receives asset.js, it serves it, and at the same time caches it. This is obviously depending on the way that you would want to configure your CDN, but this is the general idea here, that if the resource does not exist in cache, fetch from the origin, serve it, and ensure that any subsequent request can be a cache hit. So that is what will happen if someone else requests for the same resource when the cache is warmed up with this particular asset.js. Yeah, it does not need to go to the origin server, right? So we have just saved ourselves one entire round trip time. We have saved ourselves the extra accumulated time that would have gone in SSL establishment, in DNS fetching, if it's a dynamic query, and in the actual payload delivery. So all of these components of the request waterfall can be optimized. This is why CDNs are so important in optimizing web content, especially that which can be cached as much as possible, right? So if you have an application, if you have a website out there, the first question you would ask yourself is, why should I use a CDN? The first and most foremost thing is that it improves your availability and response times, as we just saw. And at the same time, because it is a distributed cache, it also gives you the benefits of what a cache would. It helps absorbing traffic bursts, for example. Maybe there is something on your site that has gone viral. Maybe there are things which entail a huge number of requests to your origin servers. The CDN in the middle will help optimize that. It is going to ensure that there is no bombardment or of these requests onto your origin server, and things are handled efficiently. Alongside, you have much faster SSL termination, because the only SSL connection that is being established here is at the CDN edge. If a resource is cached, the second SSL connection to the origin is not really required. And at the same time, because the edge is closer to the user, that SSL connection establishes in a much shorter time. And lastly, you have the cache hit ratio, which basically reduces the incoming load. It's a very simple concept. You have a given set of hits that are going into your cache, and you have a given set of misses. So how many hits versus upon the total number of requests into 100. This is basically what the cache hit ratio is. The cache hit ratio is good to determine how proficient your CDN is in trying to optimize your site payload delivery. The higher the cache hit ratio, it generally indicates that you have configured your CDN correctly. There are definitely caveats to it, but this is the general assumption that we can go with. So I like to take the example of Samwise Gamgee. I don't know how many of you have seen Lord of the Rings, but Samwise Gamgee is basically carrying the payload over to Mount Doom. And this is what a CDN is technically doing all of the hard work for you, while you are maybe burdened with the dynamic HTML. But choosing the right CDN is definitely important, especially if you have users in the millions and you have an ever expanding member base. Thinking about and investing and optimizing CDNs would make a lot of sense. So this is sort of a basic introduction about CDNs, but the talk is not just about CDNs, right? It's also about China. Now, why specifically China? Because there are reasons to it, but the first why I had my experience in onboarding a CDN in China is because that is what my initial project was. That is what I was focused on. And this is how I actually got to understand a bit more information about how network connectivity in China works. So we all know that the situation currently in China, it just comes in the news all the time. But the general idea is that there are a lot of members in the country, and there is an ever expanding member base there. in terms of the applications that they would want to use, and just the tremendous opportunity that exists over there. But also there is this small caveat, which is popularly known as the Great Firewall of China. Now, what the Great Firewall is it has two parts to it. There is a technical side, and then there's a legal side. The technical side is basically some obfuscated measures to ensure that traffic is in some ways being it's not flowing as freely as one would want it to. And at the same time, there are certain legal restrictions that happen. Also, there is this very specific component of what called ICT compliance. It goes more in the legal side, so I won't really talk about it. But the general idea is that if you want to host any service in China, you need to have a service that belongs to China. And you need a Chinese company to have at least 51% stake, but that just goes, again, in the legal side of things. The idea here is that beyond the Great Firewall, you have the CDN provider, which you have to use because of various technical and legal regulations. So it is important for us to take a more closer look and be sort of and try to understand how is it that we can measure what will be the best option for us, because we want to improve performance, right? And at the same time, we want to improve network performance. We want to enhance whatever connectivity we have to our members in China. And as we just discussed, CDNs are a good way to help you with those network enhancements. It's a good way for you to reach closer to your members and serve content in an optimized way. So the entire objective here, the exercise that we're sort of coming across is we have to choose infrastructure in China, and we have to make sure that the connectivity happens to our origin data servers. So the evaluation part is something that is, in my opinion, a very important phase of deciding to have these enhancements. So we can just jump right into what the evaluation is going to be about. And I'll take a step back and I'll just show you this image. Okay. By the way, this is just my cajon. It's from a company called Clapbox. FYI, they have not sponsored me. This is just an instrument I like. So I'll come back to this picture in a moment, but I need to sort of discuss this idea with you first. Whenever there is any testing or any evaluation that happens with any component, and I'm not even talking specifically computer science, there are always going to be broadly two ways to go about it. There is going to be one aspect where you have complete visibility on every single thing that exists in that particular system. Like if I'm talking about debugging anything that is happening on a Linux server and I have access to dmessage, I can have access to all of the var logs and try and tweak and understand my way around what it is that I really want to do and why is it not happening. But then there is this other side, this other way of testing, which some people call as a black box. The black box is where you don't really have that much insight into the internals. You do not really have that much information about how a particular system, be it distributed or of any other kind, is working on the ground up. The only thing you have, the only information you have, is that whatever the behavior of any stimuli would, right? You give it a certain input, you get a certain output. And there is no actual insight on why is it that output was given. I mean, you can take an informed and intelligent guess. You maybe already know how that black box should probably work. So the idea for testing black boxes is that you need to have a more intelligent and informed decision into saying that this is the kind of experiment I want. This is the kind of test I want. This is how I would want to evaluate a particular black box and actually get this complete picture on, is it doing what I would want it to do, right? Now, why am I talking so much about black boxes? Because having just discussed how the network situation is in China, and how we have various components that could be third party vendors, could be something that a particular company owns, but the general picture there is that things are of a black box form. Things are of a form where you do not have complete insight onto how is it that something's functioning. So what can you do? Just have your respective inputs and just make sure that at the same time you are able to get these outputs, try different inputs and try and correlate the outputs, try to figure out that is it working as deterministically as you would have hoped to. So this is the idea here, that that this is what a black box does, right? Now, if we try to come closer to our topic, the one that we of actually evaluating a CDN, then we can try and just imagine that this network component is just another black box. And then we design experiments which are very specific to how a CDN functions, right? We try and understand what CDN is as an application. We now try to apply basic principles of what a black box testing is going to be about. And then we have these experiments designed, right? So I hope the idea has stuck with you a bit. I've just floundered my cajon around in a lot of pictures. So I hope it has stuck a bit. But before I go on to the next section, there is just like 3 terms that we can quickly go over. The time to first byte, first of all, it is exactly what it sounds. That sounds like whenever you're making a request, the time taken by the server to return the first byte. It's not the entire content that has to be loaded or rendered. It is just the first byte. For the entire content to be loaded and for it to be rendered by the browser, we have something called as a page load time, which measures things more effectively if you are interested in the overall functioning of a site and how the member experience is supposed to be. There's another term that will come somewhere in the subsequent slides. It's called synthetic traffic. Again, it exactly sounds like what the words mean. Synthetic as an artificial, and traffic. So there is traffic that is being generated either for the purposes of testing, monitoring, or any other use case, but it is not actual member traffic, right? So just these 3 terms, just keep this in mind a bit, and we'll just move on to the next one. So yeah, our black box has now become a CDN black box, and we will now try and see what it is that we need to input to it, right? So you have a CDN black box, and the first thing I need to do is just evaluate the CDN by itself. I have a certain system. For a given set of inputs, it gives a certain set of outputs. Now, how can I really test this? Test it as much as I can, like have as many different possible ways that I can query this particular black box, right? The one very effective way of actually measuring a CDN is using beacons. Beacons is just a small object, and the good thing about beacons is that the time to first byte and the page load time, the script load time, or the entire load time of this particular resource is almost similar, since the beacon is negligible in size. So it is this very interesting way of trying to have trying to check your net CDN configurations and measuring if the CDN is working as expected. For example, you can set a beacon to always be a cache hit, to always hit the CDN, if there is, which is how a normal behavior should be. But you can also set a beacon to always bypass the cache. And by bypass, I don't mean have any other way around it. Go through the CDN, get a cache miss, where the CDN realizes it does not have this particular resource, and then the call to the origin is made. If you remember the example I had just given you earlier, right, of how a CDN functions. So the cache miss will basically happen again and again. This is super useful. This is going to help testing in general, and will really give you an insight onto the metrics that are involved with cache fill traffic. What I mean by cache fill traffic is simply request to the origin, and how much of that, anything that does not exist in cache, I mean, basically trying to fill it. It is the cache fill traffic. Alongside beacons, you can also look at images, videos, chunks, scripts, anything that suits your configuration. Depending on your website, you can have separate classifications, and it is up to you to actually decide and understand how is it that a CDN is supposed to be evaluated. At least from these pointers, right? So this is on the input side. Now, what do we test? As I mentioned before, you can test the time to the first byte to just measure the network latency, to just see what is the time that is really being taken for the entire traversal to happen. And this combined with, say, for example, the cache miss beacon that I talked about could be useful, because you're now able to see the latency of the entire path from the member to the origin server and back. Throughput is again something that needs to be measured, because CDNs serve a heavy payload to the users, right? The content that is being served in general, whatever nature of the assets are, it generally has a bigger size than what an HTML page would. And you can also look at the page load time and run Selenium scripts if you're interested to try and figure out how much the entire rendering process takes, so on and so forth. So this is what any particular network component might be tested with, any network component that is a black box. But I also want to see CDN specific metrics. I also want to know that is the cache hit good? How is the performance of a cache hit object? Is it being fetched in the correct time using the metrics that I specified earlier? What is the cache hit ratio like? If I have a certain set of traffic and I know that I am expecting at least this much caching to happen, then am I hitting that value? Am I able to benchmark and see that based on the diversification of my assets, I am able to get the CHR that I want? And at the same time, cache miss with whatever payload sizes you might have. And as we talked about, it's the cache fill that goes to the origin. So these are like different ways that you can think about what the input could be, what the output could be, how do you analyze, how do you measure it, and there also could be discussions on how you analyze it, because you need certain agreements, or you need certain benchmarks to already have existed, and you need this sort of this baseline with which you can progress and evaluate a CDN. So you need these base thresholds. Benchmark values is going to help if you already have a CDN. That's definitely a good thing. And at the same time, if you have any service level agreements that you have established with anyone who's using your site, or any downstream dependencies, that can help influence your decision on what is the threshold that you're actually looking for, right? And at the same time, how is it that you would want to statistically analyze the metrics that you get? There are multiple ways around it, but percentiles is sort of this de facto standard in trying to figure out how any particular metric performance is like. You can look at the lower percentile to just see if there are high performers and how are the high performers doing, right? If you have excellent network connectivity and everything is, there are no issues with the public internet that you're using, so how well can the CDN perform? Whereas the higher percentiles could just talk more about how much is the majority of the users that you are concerned with is performing in the particular CDN. So there are these so many different ways that you can look at and evaluate a CDN by itself, right? And there is these sort of correctness checks that we've talked about. There are these baseline checks on whether the black box is performing the way it should. And now we're able to sort of look at and see that, okay, a CDN is maybe performing the way you would expect it to. So what do we do next? The idea here now is to just compare, because there is a very good chance you're not just going with one, right? I mean, any Amazon shopping itself, there are so many options that you have to look at and analyze. And if I'm buying a new phone, there are tons of research and there is tons of testing that needs to happen. There's tons of comparison that needs to happen. Like, I need the best specs, but I also need what it is that is probably unique to that device. So many different things. So comparison is all but natural. So thinking about comparisons, the sort of de facto way of comparing anything, and if you're talking about CDNs, is A/B test, right? And A/B testing is nothing but you're basically trying to compare two different components in a setup that is as unbiased as possible. You have an experiment that is set up. You have two separate components that you will try to vary. The input that you get should be as random as possible, so that there is no bias that creeps in. And whatever the output is, how the output performs, all of those things in turn is now going to make the call for what your A/B test is. Generally, A/B test is used for user member experiences, which kind of ties in with a CDN evaluation, because in the end, a CDN is going to help improve member experience, but maybe it is not as visual as a traditional A/B test would be. But in the end, it is still testing performance, which in turn might dictate how satisfied a user might be with your particular website, right? So the important thing here is to remove bias. That is a word that I'll be throwing around a bit more in the subsequent slides. But it's still, the reason why I would do that is because the concept of having an experiment that is as unbiased as possible is super important. It dictates how successful your test is. It dictates how successful your evaluation was, and whether you are actually getting the results and in turn the performance improvements that you would have hoped for. If your experiment has issues and there are problems with how is it that you came to the conclusion, it might not really go in the way that you would want. Now, I won't spend much time on this part, but clearly by now we've understood that since we're comparing CDNs, there are going to be requests that are coming, right? There is going to be a particular inflow of a ton of requests that go to either CDN A or CDN B, and they will have their respective responses. How the responses were, we measure them, and then we figure out that this is what really happened. Now, the requests that are being generated, they could be synthetic, and they could be real traffic. Synthetic has the capability of at least testing the correctness of a particular CDN. And if you can really emulate how your traffic is, which is possible in certain situations, it can also serve as a good input for your A/B test. But generally, the way A/B tests are conducted is definitely on real traffic. There is going to be a given set of requests. There is going to be a given set of allocation, which also needs to be correctly handled. But there is real traffic that will now be used in the final A/B test to figure out that, oh, this CDN is better, or this one is much worse. So taking a bit of a step back from all of the approaches that we had talked about I had in the previous slide, this one, and I had just slowly tried to come to the methodology that we generally think in terms of. You have basically evaluated a CDN by itself. It looks good. You have paired them together. Now there are two CDNs, or even multiple. There could be any, and then now you need to compare them. So the question here, the first question that maybe you should be asking is that how is it that we will distribute traffic amongst these CDN providers, right? There could be different ways to go about it, because what are the different measurements? What are the different strategies that we can use? So strategies are something that you can just think about while I discuss the methodology behind at least distributing traffic. Giving us a phrase, so I'm talking about how is it that we can steer traffic, and how is it that we can move around traffic between these particular CDNs. Now, it's public knowledge that LinkedIn utilizes Sidexis, and Sidexis is basically implements the concept of RUM DNS, or real user monitoring. It's a simple concept. You basically have a user that is querying to a particular endpoint on Sidexis, and then Sidexis makes the call and says that you should either go to A or you should go to B. So it's Sidexis' decision, first of all. How does it make that decision? It is configurable. There are different strategies that you can apply. One major advantage here is the real user monitoring part, where what really happens is that you have this feedback loop of how an old user performed in this particular region, for example, having these particular features when I sent it to CDN A. So when you're sending it to CDN A, and when you're trying to get when you found out that Sidexis just understands that CDN A was probably the right choice because the user is reporting favorable metrics, compared to a user that I had sent to CDN B. CDN B was not really the good choice for someone who was probably in this region, or had this ISP, or was connected through this subnet. There could be multiple ways about it. And Sidexis takes all of these things into consideration and has this feedback loop. It just gives you this input here. It just says that I am looking into all of the features that this particular user will have, and I will allow you to have your pluggable strategies around, which might simply say that, okay, just go to the better optimal CDN, the one with the lower response time. So Sidexis gives you that flexibility. So this ties in with our earlier discussion about how do we conduct an A/B test, because now you have you have CDN A and CDN B, and you need to distribute traffic, right? So this is when I'll start. Now I'll actually start talking about what we did and what our case study was in bias. I told you I'll use the word a lot. So this is the basic experiment we designed. This was the first setup that, okay, now we've understood the idea, now we've understood the approach. We have a basic understanding of the fact that these are the things we need to measure a CDN on. This is how we need to compare it. And now we just need to distribute traffic and then measure all of the metrics and get whatever statistical analysis is that we want to, right? Now, how do we distribute traffic? Members come from China, since this is just localized to China, because the CDN itself is also localized to China. The CDNs themselves are localized to China. And there is RUM steering, the concept we just talked about, where you have a given strategy and multiple CDNs can now get traffic based on what that strategy dictates. Now, the question is, what strategy? The strategy is you compete for requests. You compete depending on your performance. right? The better you perform, the more traffic is going to go to you. If your latency is lower, if your cache misses are good, if you are in general able to have a higher throughput than your competitors, then all the more traffic to you. And we serve more traffic to that particular CDN. We serve traffic to other CDNs as well. And we measure observable defined metrics and then do a final analysis, right? But there's an issue here. Now, this is something that we saw after we had conducted the experiments, and then we were doing sort of the post-experiment analysis. If you've already thought about what could go wrong, then awesome. I'll just go, since I'm a little short on time, I'll just go to what the bias was. More traffic means more data points. CDNA is getting 45% of our traffic requests, right? CDNB is getting 37, C is getting 14, D is the neglected CDN. And you would expect that CDNA, the way Sidexis is actually trying to monitor CDNA, it is definitely performing the best, be it on all of the percentiles actually, 50th, 75th, 90th, all of them. CDNA is definitely the best. But because it's getting more traffic, it gets a higher percentage of good performance, which is nice, helps its numbers. It also gets a higher percentage of bad performance. That could be as a result of maybe just poor connectivity in a particular region. Could be just any other unforeseen situations that has caused it to be on the other side of the bell curve. But because I'm getting almost 50% traffic on CDNA, there is also a higher number of bad performers that I will be getting. What does that lead to? Sidexis says CDNA is the choice, you should go for it. But our internal tail end metrics say that, hey, don't choose CDNA. It sucks. And that is contradictory, right? How do we really go about deriving any conclusion from this? So the very simple idea is to say that, hey, Ram, I know you're trying to help. I know you're trying to give traffic to the better deserving CDN, but don't do that. Let's just do round robin. Let's just have an equal distribution of traffic. Let's just go from divided equally, and there is going to be some performance impact, because now a CDN which is not really performing as optimally as another one would, which probably deserve more traffic, is still getting an equal number of requests, because of which the users that are going to the subpar performing CDN might get some degradation. But in the interest of having fairness in the experiment, that is a compromise that was agreed upon, and equal round robin was initiated. Obviously, there is this minimum availability cutoff. Like, I will not serve traffic to a CDN that is simply not able to serve or get any responses back, or if it is black holing traffic for whatever reason. But there is definitely a minimum availability cutoff, but it's not as stringent. It is still a bit lax compared to what we would have expected in a RAM-based situation, where RAM itself takes care of ensuring that our requests go to the optimal CDN, right? So we had an equal traffic distribution. Every CDN was given an equal opportunity, and all of them got the same amount of traffic. And yeah, we now see that Sidexis on the front, on the head side, and all of our metrics on the tail side, they correlate, and they have they're basically consistent with each other. So yeah, that is basically unbiasedness managed, right? So I'll just conclude this talk. We need CDNs to try and optimize our site payload delivery. It helps deliver a better site experience for your members. And if you're looking to expand in China, it is definitely a promising market, but it has its own shares of hurdles, right? It has its own caveats that you might get past. Those caveats can make you frequently run into closed systems, and it might help if you want to evaluate a closed system. You just think of it as a black box. Understand what input you want to give, what output it will come out, and how do you want to measure it. Once you know that a black box performs the way it's supposed to be performing, if you want to compare, do an A/B test. Try and conduct comparison. But yeah, you need to be as unbiased as possible. Experiment design is everything, right? And there are different ways that you can route. RAM steering is something I just specifically talked about for the sake of this talk, but there are definitely other ways as well. And as we had seen, there's more traffic that is given to a particular component that just introduces bias, right? So thanks everyone. Thanks for listening. And if you have any questions, I can take them now.
Thank you, Mridul. Thank you for the wonderful. It was refreshing to see CDN, SEPs, and all those technologies all over again. We have a couple of questions from Subham. Let's do one thing, Subham. Since you have multiple questions, I would unmute you, and you can directly ask them. Yeah, please go ahead. Shubham?
Shubham, you're on mute. You have to unmute. Yeah.
Hi. Yes.
Yeah.
Can you hear me?
Yeah.
I can hear you.
Hey, Mridul. Thanks for the session. Yeah. So my question is regarding, are there any open source tools or shared infrastructures through which we can conduct synthetic tests for black box testing? Because that's one area that I see. Web page test does provide the platform, but it's limited by resources again. And Sidexis, Catchpoint, these are paid resources. So do you see any upcoming wave for an open source solution for black box testing of CDNs?
Yeah, that's a good question. It's something that I feel a lot of different traffic analysis, be it cache warming, be it just simply trying to test any network component, tries to rely upon. Unfortunately, I don't know of any that is at the level as these proprietary solutions are. I can get back to you for this offline, but at this, I'm guessing you're asking at the scale at which this evaluation was done, right? At that level, yeah, I'm not aware.
Okay. The other question that I have is regarding cache hit ratio. So in my experience, I've seen CDNs sort of misrepresenting the data by mixing revalidation request as a form of cached content request. How do you consider revalidation requests for short-lived TTL content? Do you consider them as a part of cache hits, or you don't?
Do you elaborate more on what you mean by revalidation requests? Like it could vary from context to context.
CDNs have the content, but it's expired. There is a request. So CDNs will send an IMF request if modified since. Instead of getting the full content, they will send. They'll get the response from IMF that it is good to be served from the cache. So would you consider those requests as a part of cache hit or cache miss?
So there is also the concept of how a CDN is handling these internal, these expired requests, right? And there is, since if it's a bigger file, then partial requests might be something that your CDN intrinsically supports. So it could also happen that you're trying to have these various chunks that are being utilized and fetched independently, and those could be sort of this independent entity when you're trying to establish what a cache hit is. But we definitely do we definitely consider the new one as a cache hit resource, as a resource that we would if it has expired, and we have a different way of handling expiry, but which I can't really talk about in this talk. But definitely there are means and measures that we can use to try and have these various chunks have be a cache miss if the content is expired, and independently fetch them, and make sure that the cache control values are basically respected by that particular CDN, and it's served correctly. I don't know if that answers your questions.
Okay. The last question I have is regarding availability SLA. Do you guys track availability SLA and put claims against violation for this?
We have this internal communication that happens with all of our CDN providers, and there are definitely certain expectations and certain agreements that are there, that are established in terms of how is it that we would want that particular CDN to perform, as is with any other third-party service. There are individual outages that we would ideally want them to be made aware of, and there is also to the best of my knowledge, also this SLA that is tracked.
And do you claim against the SLAs?
I'm not sure about that, because that comes under more of a contract and legal situation. We do have the numbers, we do have audits, and we do have ways to actually understand that is the CDN performing as we would have expected it to. But what is sort of at least the monetary side of things and the legal aspect of things on what it is that we choose to do with the information is something that I unfortunately can't divulge, and I'm not much aware about either.
That's okay.
Yeah.
Got it. Okay. Thank you, brother.
Yeah, no problem.
Thanks, Shubham, for the questions. And just to reflect on that question you asked about revalidation, right? From what I understand, the revalidation sequence works like this. Your cache expires, and then when a request comes to that expired cache, a request is sent to the origin server to revalidate whether I have the same the cache or the original still has the same version of the image or the asset, or if it's a new one. If it's a new one, that ends in fetching a new asset, right? New version of the asset. And if it is not, it just gets a response. The CDN just gets a response back saying that okay, this is the same version, and in that case, the content is out of cache itself. So it's just about the time, right? The expiry set on the asset has expired, but the asset remains the same. So in that case, if in the origin the asset is the same, in that case it doesn't result in the actual data transfer, right? It is just a web request only. So I would say that in itself is like so the asset is still served from the cache. So revalidation request, if it's a positive revalidation, it definitely is going to be a cache hit and not cache miss. But the cache miss happens if there is the origin has a new version of the asset. So that would be like the right take to take on that one. Okay,
Sure.
let me look at other questions. So far we only have this question. Anybody has any other questions, please post them on the channel or on the YouTube link provided. We would also try to get back to you even after the event if you have questions. Let me just go through the questions once again if there is anything else. Okay, I don't see any more questions here. Let's see. As I said, you can ask the questions later as well, either here or in the meetup.com as well, wherever we will try to answer to the best of our abilities, and the panelists would be also happy to help on that one. Thanks, Mudul. So we had 2 talks for the day, and both are over now. But before we conclude the event, I would like to invite BG Sudhagar to say a few words. BG is heading the infrastructure SRE team, including the traffic SRE in LinkedIn Bangalore. And he has been a very active and supportive force behind running this meetup. While we would like to thank him for his support, right now what we want him to do is say the word of thanks. So over to you, BG.
Hey, thanks, Safir. And as Safir mentioned, I lead the infrastructure SRE teams here in Bangalore, and Edge SRE, which CDN is part of the Infra SRE charter. Very fascinating set of problems in that domain. Just in general, edge traffic routing and optimization, efficiency, performance. So I personally have a strong interest in this area, and I'm happy to see this engagement and interest in it as well. The question that was asked was a very interesting one, Shubham, and I think Safir, his explanation was spot on. I don't want to get too much into the technical details of it, but I'll just spend a minute or so on it. I'm an engineer first and foremost, so I can't resist, speaking to engineering things. So I feel like, if the origin, if CDN tries to do a revalidation of origin and then serve the request and claim that as a cache hit, that's fine. What they should not do is extend the cache duration after that, right? Because that's not something that the origin has authorized them to do, right? So in other words, what will happen is once the object expires from CDN cache, every subsequent request would then either have to be a revalidation request, right, to origin without repopulating the cache. Now that's an optimization that the CDN may want to do. I can't see a good reason why they would want to do that and increase latency for the end user versus actually just refetching the origin content and repopulating the cache. And when they do that, they also get the ability to figure out if cache control has changed, for instance, from origin, right? And then they can legitimately store that object for that duration in their cache. So just wanted to call that caveat out. So with that, I would like to thank the speakers and presenters today for very engaging and interesting talks on both topics, right? Observability and CDN evaluation, specifically in the context of China. So thank you to the speakers, right? I'd also like to, I know this has happened with Apu's keynote, Saturday AM, just making the time for an event such as this. I think it shows the level of, curiosity, commitment to these topics, right? And an interest in learning more about some of these complex things. So I really, really appreciate the fact that folks took time out to show up here, and more importantly to actually stick around all the way to the end here. So thank you, folks. With that, I'll hand back to Safir.
Thank you, everyone. I think there was one more question from Naman to Mrudul. Mrudul, do you want to take that?
Yeah, sure. Go ahead.
So does revalidation happen based on MD5 hash between cache and the source server? So I'm assuming this is about the ID of the asset.
The revalidation actually depends entirely on the kind of rules that are being set. I'm guessing that you're talking about when is it that a particular resource is a cache hit or a cache miss, and how do you check if a particular asset is can be served again? So there is the main thing that you need to take care of is like, for example, we have certain assets which already have a hash inbuilt in the URL itself, which ensures that there is uniqueness, and you don't, the URL itself acts as a cache key. So that definitely helps you in trying to check in case of any revalidation. This is alongside obviously the revalidation discussion that just happened on the if modified since. So yeah, it's the answer would probably be it's a mixture here.
Okay, Naman, I hope that answers your question. All right, okay, yeah, got it. Thank you. So, folks, again, once again, thanks for joining us, and this concludes our event. Panelists, please stay back. Attendees, you can drop off. Thanks again, and have a good rest of the day.
Thanks, everyone.
Bye, folks.
Guys, I would request all panelists to turn on the video. Pooh, you're around? Apu? Can somebody call Apu just for a moment?
I can do that, Safir. Just give me a second.
Anishal, you can stop the live streaming now.